Let's talk now about the second quality of service component, which is classification. Classification means distinguishing one type of traffic from another. Before moving on, let's just mention that if you read all documentation for some switches, you will see something that is referred to as classification by ACL or quality of service ACL. Notice here and here. This is the diagram coming from the 2960 Cisco Catalyst switch, but you will find it in other switches as well. Just think that they are referring to class map ACL classification. Remember that a modular quality of service CLI has been available in several switches, in all switches as well, but they had a subset of what we now know as MQC. So just bear in mind that you may enter some MQC commands in all switches, but you might not find the whole set of commands that we have nowadays. So let's continue. So with classification, you want to distinguish each flow and place it into what we know as a class map. So we want to distinguish voice traffic that is entering our switch and place it into a voice class map. And we want to identify video traffic that is entering into our switch and place it into a video class map, for instance. And we want to identify database transactions traffic and place it into an adequate database transaction class map. And if we have some traffic that cannot match any of our classes, we are going to place that into a default class map. This is basically the idea behind classification for Cisco. So the way it works is the following. I'm going to try to explain this in a fast manner because a lot of engineers out there know how this works. So this will be the algorithm in order to relate a traffic flow to a class map, which is the actual classification method that we want to set up in the switches. So first of all, for one interface, for a given interface, I will configure one or more class maps. In this case, I'm going to configure this class map here. That will be my first class map. That will be my voice class map. Then I will set up a second class map here. That is my video class map. And I can create several. For instance, this class map is the internet class map. And the way it works is the following. I will apply a particular flow, an evaluation for the first class map. So I'm going to evaluate this flow with the first class map. So I'm going to evaluate these conditions here that exist in my class map. If these conditions evaluate to true, then I'm going to say that that flow belongs to this voice class map. And then I'm going to stop processing this flow any further. But if these conditions happens to be false, then I'm going to keep subjecting this flow to further evaluation. And I'm going to evaluate now my second class map conditions with this flow. If this evaluation of these conditions happens to be true, then I'm going to reach the conclusion that this particular flow belongs to the video class. It is a video traffic. And then I will stop further processing for this particular flow. But if the conditions happens to be false, then I'm going to keep subjecting this particular flow to every single class map that I have configured for this interface in a top to bottom order. So eventually I'm going to reach this internet web browsing traffic class map, and if the conditions for this particular flow get evaluated to true, then I'm going to reach the conclusion that this flow belongs to this internet class, and then I'm going to stop further processing this flow. But if the conditions for this final class map happens to evaluate this flow as not conforming to these conditions, I'm going to say that this flow will belong to the default class for this interface. This is how the classification process works with Cisco. And remember that we're talking about conditions here. So how do I set up my logical conditions? I'm going to use these commands. The match command within a class map helps me set up the conditions. So the first and most important condition that has existed for Cisco switch in order to classify traffic is access control list. So I will set up access control list, and all the traffic conforming to this access control list will be matched within a class map if I use the match access group command. I can use IPv4 access control list, max access control list, and IPv6 access control list as well, but some really old switches cannot handle IPv6 access control list for class maps, but we are talking about really old switches here. So that is the most important tool I have in order to distinguish traffic from one another using ACLs, but I can also use marking. And I am going to use the marking that this traffic already may have when it arrives into my switch. I can use the marking coming in layer 3 packets or in layer 2 frames using QoS. So these conditions have been available for several years now, but in recent switches I have these other conditions as well. For instance, for the Catalyst 9000 series, I can use MBAR. So with MBAR, I can match the protocol. So MBAR will help me to identify protocols up to layer 7. So I can identify YouTube streaming traffic, Facebook traffic, Zoom, video calls, and so on. So this is actually really cool to distinguish traffic. I can detect missing MAC addresses in the MAC address table. I can detect packet sizes, scalable group tags, quality of service groups, wireless LAN numbers, VLAN numbers, for instance, in Catalyst 9000s. So if I want to have a more complex condition, I can have combinations of these matches. I can add or put together several conditions in such a way that I can have a more complex evaluation. So for instance, if I set up my class map using the match any parameter, I may have several conditions joined by the OR clause. And if I configure my class map using the match all parameter, which is the default, I can have several conditions joined by the AND clause. So I can have more complex conditions in order to distinguish my traffic. So how do I actually configure this? First, if I am going to use ACLs, I have to define my ACLs. Then I have to set up each of my class maps. For each class map, I'm going to enter the command class map and then the name. The name should give me a hint about what is the usage of this class map. So for instance, I could use invoice. So this name tells me that I am going to use this for incoming traffic into a port, and I'm going to try to distinguish voice traffic with this class map. Or I can use int video. So this class map name tells me that this particular class map will be used for incoming traffic and in order to classify video traffic. Or I can use out voice, for instance, and this tells me that I am going to use this class map in order to classify traffic that wants to leave my switch. So the outgoing voice traffic, for instance. So choose this name in such a way that it makes any sense, that gives you a hint of what is going to be included within this class map, and then choose whether you are going to use match any or match all. Remember that match any means you will use several conditions joined by an OR clause, or you can use the match all, which is the default. That means that you will join your conditions using an AND. And then you can use all of these conditions in order to distinguish your traffic. So let's see some examples. This is, for instance, an ACL based class. So we are going to set up first the ACL. So we are going to identify here all the traffic that comes from this host to this host. Then we are going to build this class map. This is the name, ACL 101, and it is going to match an ACL using the command name access group, and then it is going to match exactly the ACL 101, which is this one. So if I use this class map for incoming traffic, for instance, that will mean that all traffic that is entering my switch that happens to be originated by this IP address and destined to this IP address, then that traffic will be referenced by this class map, ACL 101. So this access list can be as complex as I want. For instance, this access list that is named TCP matches all TCP traffic destined to port 80. So I can create a class map that is known TCP, that will be named as TCP. It is going to match an access control list. And which access control list? TCP, which is the name of this access list that I created. So if I use this class map for incoming traffic, for instance, all traffic that is going to enter my switch that happens to be TCP aimed to the port 80 is going to be referenced by this class map. So in this example, I am using another access list to identify all UDP traffic destined to port NTP. My access list is named UDP. Then I am creating here a class map that is named UDP, and it is referencing an ACL. The condition here is all the traffic that is going to match this ACL that is named UDP. So I am classifying this traffic that is UDP destined to NTP as class map UDP. Now, this is another example. This is a more complex access list. This is named RTP, that includes all the UDP and TCP traffic destined to port 554. And this is the class map that is named RTP. It is going to match the access list that has the name RTP. So all this traffic with these characteristics will be distinguished or classified as class map RTP. I can also create MAC access list. Here I am creating a MAC access list named MAC list 1 and a class map named MAC class 1. It is referencing an ACL, but this ACL happens to be a MAC address ACL. So all the traffic whose MAC address matches this will be classified as MAC class 1. Okay, we have seen how access lists work, so now let's see how working with markings will work. So in this case, I am classifying all the traffic that has the cost value 3, 5, 4, and 5 with this class map named cost. And with this class map named dscp, I am identifying all the traffic that has the dscp values AF21, 22, and 23. And with this class map prec2, I am identifying all the traffic that has the precedence set to 2. Now for recent switches, I can identify all the frames that belongs to VLAN 120 with these commands, and I can also use quality of service groups. So with quality of service groups, I can create these virtual groups that exist only in one switch. I can have the quality of service group 1 and quality of service group 2, and have some traffic flows belonging to quality of service group 1 and some other traffic flows belonging to quality of service group 2. Inside the switch, these frames will use an internal header that only exists in the switch that will tell me to what quality of service group they belong to. Now, when this traffic tries to get out of my switch, then I can apply some action. So for instance, for quality of service group 1, I will say the priority queue. And for quality of service group 2, I'm going to reserve a bandwidth of 20 megabits per second. So I can take some actions when traffic wants to get out of my switch, depending of the quality of service group it belongs to. However, these are locally these quality of service groups only have a meaning locally. So if I have another switch here, switch number 2, this is unaware of to the quality of service group these flows belong to, because quality of service group have a local meaning. Quality of service group will not travel with the traffic. They are not a marking. They only exist within the realm of one single switch. This is a more complex example. We are enable N bar here. So given we have enabled N bar, you can match a protocol. Notice that this class map C1 has several matches. Given it is a match all class map, there is an implicit AND between these matches. So a traffic flow will have to match all of these conditions in order to become part of this class map. So in this example, we are setting up a scalable group tag 24, and we are setting up a scalable group tag access control list that says that traffic that belongs or has the scalable group tag 24 can communicate with devices that have the same scalable group tag. And the final example is what is known as hierarchical class. So you can use a parent class that makes use of child classes. This can help you if you want to achieve more complex logical operations. So for instance, remember that one class can be match any which will be executing OR, and also one class can only be match all, that will be executing ANDs. So if you want to achieve a more complex logical condition, when you have a condition 1 and condition and 2, or condition 3 and condition 4 or condition 5, so this will be a really complex condition for a class map that you cannot achieve in a single class map. You can use hierarchical classes in order to achieve conditions such as this. So let's a final point here. You can use classes for inbound and outbound traffic. So if you have a port here, you can have an inbound set of classes configured for the traffic that is going to enter your switch. So you are going to classify the traffic that is entering your switch. And you can configure an outbound set of classes in the same interface that is going to classify the traffic that wants to exit your switch. So bear in mind that you will have inbound classes and outbound classes. And just a final point, remember that you have a switching domain or quality of service domain, whatever you want to call it, where you have access switches, distribution switches, core switches. And you might want to apply really complex inbound classes for traffic that wants to enter your domain, because this traffic comes from an untrusted source. So you might want to use all the tools available in your inbound classes. You might want to use ACLs, you might want to use mbar, and you might want to use all your tools available in this at this point, because this traffic is just entering your domain and you want to make sure that it gets classified correctly with as much detail as possible. However, when your traffic is traveling inside your domain, when it is inside your domain, you don't really want to create complex classes here. You are going to use a more simple classes. You don't really want to go or be extremely detailed on your classification here. You are only going to trust your markings. So the complex classification happens here when traffic wants to enter your switching domain, but once the traffic is traveling inside your network, in your inner network, your classification can just rely on these commands. So let's put an example here. Let's say you have this network and you have this set of commands here and you have this set of commands here. What sets of commands would you will use for your class maps with this example? So notice that these devices are user devices, and here you have a switch that you are not managing. So there is something that is known as trust boundary. So this will be your trust boundary. You don't really trust the markings beyond this trust boundary, and you are going to trust the markings inside your trust boundary. So I'm going to mark with this color. This arrow means class maps that are going to be a little bit simpler or simple class maps or light, however you want to call it, light class maps that are going just to rely on markings because they trust that in another point of the network a really detailed classification was done. So for instance, here I will use a light class map for inbound and outbound, here as well, here as well, here as well, here as well. And the outbound class map here will be a light one or simple one, trusting markings. So notice that when traffic arrives from the inner network, I'm going to use a really light class maps. And even for these outbound class maps, this traffic is leaving my inner network, so I know I am ready to trust that traffic. Now, in order to classify traffic that comes from outside the trust boundary into my network, I am going to use these sets of commands because I am going to use all the tools available to me. I am going to match access control list. I am going to match MBAR protocol because I want to be really detailed with the class maps. For instance, here and here, because this traffic comes from a switch that I am not managing. And I'm also going to do that here because this traffic comes from users. And I don't want to trust the markings that the users can place on their traffic. I am going to be very careful with this class map. So the green arrow means complex class maps. And with these complex class maps, I'm going to use all the matches available, access control lists, MBAR protocols, and so on. Because I have to be really careful with this traffic because this traffic comes from outside my trust boundary. Hope that makes any sense. That's it.